Good. So now we have captured the spectrum. When I press next, this software will now go in and do the diagnostics on it. It will analyze the reference data and ensure that we have what we're looking for. So in a little bit, and the time it takes will depend a little bit on your internet connection and a little bit on how good of a scan you did. But it should never take much more than a couple of minutes. So what we see here is that we have a 85% quality, and we see a nice fit of the model fit on it, which means that we can go on to the next step. So now it says sample measurement, side A. And when I look over here, what we see is that I have to empty the vial and then rotate the sample. So we actually get it through the cuvette, but not through the filter itself. So I'll just do that straight away now. So the first step is to empty the cuvette itself. So I'll just dump out the reference liquid. So we have prepared a solution of 1% sugar and water. And then I simply repeat the experiment as I did before by first loading the cuvette. So I'll take a pipette, I will angle it as I did before, and then fill it up for the top, making sure to fill adequate liquid in to get above the filter itself. And now as I tilt it back, I can clearly see that there's no bubbles on the crystal. Going over to the instrument. Now I have the filter here, here pointing away from the light. So when the light goes through the cuvette, there's no filter within the path lengths. Then I go back to the software and press capture.
Is there a reason why water was used in the first measurement and this new solution is used in the second measurement?
So we use a DI water as reference in order to make sure that the system is calibrated. So
it's a type of check, or
yeah,
like a health check? Or okay.
Yeah. So we check for two things when we do the DI water. One is that the instrument itself does not induce any errors that was unexpected. The second thing we do is that we check the quality of the photonic crystal. So the small window you see within the NanoCuvette. And if the crystal is of too bad of a quality, the software will tell you, you know, this is not what we expect. Either wash your cuvette again or take a new one. So if people are very good at cleaning their cuvette, they can actually end up reusing it up to 60 times. So that's the standing record in our laboratory. Typically, we see people being able to reuse it between 1 to 10 times, depending on how good they are at maintaining it. So let's say that you are working with very sticky medium or sample, then of course the reusability also goes down. The same goes if you use something that is very harsh. The key element of getting the cuvette to work for a long time is to make sure that it's not submerged for too long. So effectively, the faster you are at doing the measurement, emptying it out and cleaning it and drying it, the more reuses you can get out of it. So if we look at the spectrum now, then you see here between 600 and 800 nanometers, we do not see the resonance we had before. And that's because the light does not go through the filter. So what we're measuring here is the traditional attenuation measurement that is typically done in the spectrophotometer. So that's always sample A, which is going to be the traditional method of doing a colorimetric scan. The sample B, or B side, that we will go to afterwards, will be through the crystal, where we will measure the resonance and therefore also the refractive index, which directly correlates to the Briggs value. And when we go back to the report, I will show you how to configure that in order to have a clear signal. The reason why I chose to do sugar and water is that sugar and water has no clear attributes within the visible part of the spectrum because it's a transparent solution. So effectively the attenuation shows no correlation between sugar concentration and attenuation. And the interesting part with that is that it shows that attenuation cannot be used for measuring bricks, but if I rotate the cuvette, we can measure the bricks value. Of course, if you had, let's say that you're measuring the quality of wine, you would have a colorimetric response within the visible part of the spectrum as well. So that would just be an added information that you can get from this spectral analysis. Good. Then it says now that I have to do a sample measurement side B. And then I can see over here in the animation that it says rotate the cuvette 90 degrees, so the light goes into the filter. So we'll put it back in again. And then we'll go back to the software and say capture. So the only thing that you need to be aware of when you do these type of experiments is that where is the light source and where is the detector within your instrument, because you need to always follow the light direction when you insert the cuvette. So what we typically do with instruments that we use very often is that we put on a small sticker just indicating the direction. So when this step is concluded, then the software itself will do all of the analysis, and it will also generate a report. Then when we look at the report, we will see if our findings make sense or not, and then we can configure the report to our specifications in order to create a bespoke version that is also generated on all of the dataset. And this step saves a lot of time. It installs direct best practices, meaning we minimize the likelihood of error. What we're seeing now as we are beginning to go towards the 600 is that we should start getting the resonance of the crystal again. So it starts going up here. And to the naked eye, it will be difficult to see, but there will be a slight shift in this resonance. And that's because the sugar-rich water has changed the speed of light within the sample. And therefore, the resonance of the crystal will shift accordingly to this change in speeding light. And that's how we can measure the sugar concentration based on refractive index, which is a direct measure on the speed of light. Any questions to that?
No.
Good. So we'll just allow it to conclude this measurement, and then we should be able to generate a report and configure that. So I've also prepared a sample with 10% sugar in it, so we can repeat the experiment just to show that the bricks value actually scales with the concentration of sugar. I showed before that there was no response to the sugar concentration within the visible part of the spectrum, and now we see there is clear response, there's clear features that we can track. And this is what is introduced by the photonic crystal that we use to get these results. We'll just allow it to scan to the end. So when we press next now, what will happen is that the software will calculate. So in order to maintain the quality of my crystal, I will empty it out immediate in order just to make sure that it keeps dry while the software is calculating. What we see here now is that we see a 81% match, which is a medium quality fit. We do an initial visual inspection on the spectrum, and we see the model fit follows the curve. So we expect these numbers to be within our tolerances. So when I press finish, it will then populate the report in this summary page. So what we see here is that it just gave us the refractive index and the sample quality fit and the reference fit quality. So the reference fit is how good do we believe our calibration is, and this is how good is the model to predict the refractive index. And what you see here is that we have no Brix value. So that means that I can go in and then we can say edit project, and then we have this window. So this is the values that we have selected for the report, and these are the different values you can select from. So this is kind of the library of values. And what you see here with these small gray boxes are which types of cuvette that enable this measurement. So you can see here that for the degree Brix, I can use a NanoCuvette One or a NanoCuvette S. So if I press add now, then the Brix value will be added to my conclusion. We can also go in and say, okay, I would actually like to have a data quality control on it. That I can do with the NanoCuvette One, so I can add that. There's all kinds of values that we can add by simply just pressing add here. But for now, let's keep it to this. When I press save, it will automatically go in, populate it in the model. So when I press view, we now have added the degree Brix. So this is how easy it is to measure the sugar concentration in an experiment. So what I will do now is I will increase the sugar concentration from 1% to 10%, and then we can compare this to the value here. Good.
I think, Christopher, one of our biggest questions is, because we are distributors for Ocean Insight,
yeah,
like, is the red tide the only model or that we can use for this, or are there any other spectros that we can use in conjunction with your cuvettes?
So we typically work with the UV-Vis part of the spectrum, and that's because our calibration software is made around that, and that's because we need for the optical modeling to work, we need to see the visible part of the spectrum. For every time you cut away some of the wavelength, we end up sacrificing precision on the model. So if you look at the resonance of the spectra, you saw that it went from around the high 500 up until the mid to high 800s. So you could do with that part of the spectrum, you just run the risk of having an overall shift in the data because you don't have the tail end, meaning the lower wavelength. So it's a trade-off. When that is said, we have Ocean Insight instruments here where we use them with their standard UV-Vis modules. We work together with a US-based Ocean Insight distributing company called Specology and Flash Photonics, which exclusively work with the Ocean Insight lineup as well. So the only thing you need to be aware of when you kind of couple these together is that when you design the station, that it becomes a UV-Vis setup and not a single wavelength OD or only ultra fine wavelengths or something like that.
So essentially, choose any UV-vis spectra from Ocean Insight?
Yes.
Okay.
And that is exactly the key point. What makes this product really interesting, because the only thing you need to be aware of is what is the height of the filter and what is the height of the beam height within your instrument. And then you need to have UV-vis with wavelengths, and then between, the standard resolution is around the 1 to 2 nanometers. That's adequate. When you use diode arrays, they measure very fast but very noisy. So what we tend to see is that if you average out the signal, then you can improve the signal to noise ratio, and then you can get similar results out of an Ocean Insight instrument as you can with the traditional monochromatic instruments. So it's only a matter of designing the protocol to remove the most common sources of error, like too low averaging times and stuff like that.
Okay, thank you.
Good. So I will quickly repeat the experiment here with 10% sucrose in water. And once again, I will take the filter pointing down and angle it. 2 seconds. Sorry for that. So I will angle it down again, and then I will pipette it so the liquid runs over the crystal and lifts off any bubbles. So when I turn it back, I will have no bubbles within the view of the crystal itself.
And how often should you do that health check with the measurement of just the water?
So
like once a day, or?
So typically you would do it for every measurement you make. So effectively you can by doing it in the beginning do the experiment. So when you get to this window here, you can choose a reference from your library, right? But the problem is, maybe I'll just do it all the way from scratch. So the problem by loading your sample without doing the reference measurement first is that you will end up having deposits on the crystal. So you don't really know the quality of the crystal unless you repeat this first. The cleaning protocol is just DI water, shaking it to making sure you mechanically remove any residuals, and then you dunk it out, right? And then I load it with DI water again in order to measure how good we cleaned the filter itself. Good. So I will repeat the experiment here. So maybe I'll do it in the camera here. So you see here there are some bubbles within the cuvette itself, but they are not on the filter, which means that I can still use it because it's only the bubbles near the crystal itself that is of concern. Good. So Jade, when we get the resonance now, then you can see the rough wavelength that we can use. And right now you can see the benefits of using Ocean Insights is that because this is a monochromatic instrument with mechanical lenses, it takes a long time to do the scanning with these instruments. So that's of course a clear benefit of the Ocean Insights is that with a diode array, you get all the wavelengths instantaneously. If you have more complex samples, you can choose to create other reference liquids. and you can also choose to create your own. So the create your own is predominantly for life science experiments, where you have these different buffer solutions that you use, and then you add your sample to that. And that's because these buffer solutions, they are individually designed for each experiment. But because we predominantly, when we talk Brix values, we are measuring fermentation in water with a little bit of sugar in it, then we traditionally use, for these type of experiments, we just use water as reference. So the absolute lowest that we recommend people using our technology is that you look at the valley here, so that's around the 800, and then we see these features here, and then it gets down, so that's to the 600. So you should always ensure that you as a minimum have from 600 to 800 in order to get a data set, but for every time we cut away some of the other features, we remove the accuracy and precision and reproducibility of the platform.
And then what is the parameters like? After this step, it gives you how good the crystal is. So the last measurement was like 80 some odd percent.
Yep.
So if it gets to, let's say 40%, is that when it would tell you it's not good enough, or like what is the parameters on that?
Yeah, so I think it's 75% is our threshold. So if you hit at 75% what is expected, then it says don't use it. Okay. And that's simply because, you know, if we are targeted quality control or research or academia, you really want to know within a certain level of fidelity that what you get out is actually what you are measuring. You could push it and move forward below 75 in the quality fit, but we simply don't recommend it because we want to make best practice. And given that this is a consumable that is relatively low cost, then it's easier to just rinse it again, repeat the experiment, or discard it and then take a new cuvette, right? It's not like you have to send off your instrument for calibration or anything like that. So you predominantly work with the Red Tide series, right?
No, we have not worked with that before. I know Richard can comment on that as well, but to my knowledge, we have not worked with the Tide in the past, no.
All right. Yeah, because I think that's after they changed names, they kind of changed identity, but we predominantly work with the USB model here, which is a little bit an older model. But what you see now is I actually managed to clean the crystal better than before, so we get a higher value now than we did before.
Okay.
Good, then we will take the sample, so I'll just do this. I'll not repeat all of what I was saying because it's the same as before. And of course, whenever you do experiments, you should start at low concentration and then move up. Because you run the risk of sugar residuals or other stuff contaminating your sample. So when you do a dilution series, you should start with the lowest concentration and work your way up. But that's, you know, what I recommend everybody. Oh, so what I did now is that I can see that the liquid height matches the height of the filter, which means that if any stray light hits that interface, then it can couple into that. So I just need to add a couple of drops of more solution. So now I have a clear height difference between the filter and the liquid itself. So one thing that is important to note is that the box code is also engraved on the cuvette itself. So below the number, you will see a series of letters, and this is the box code. And we decided to engrave that on the cuvette itself in order to capture if people ended up, misplacing a cuvette into a box that it didn't belong to. Then you can always cross-reference the ID and make sure that you use the right ID. It's a little bit more difficult to read the box code on the cuvette because the text is a little bit smaller and it's engraved on a transparent background. So it's not easily readable, but it is there if something is kind of not really working. So we'll just give it a... So we just launched our new website yesterday. So, but one thing that is interesting for you is that we have added a section here where you can read about all of the different applications we have. So let's say that you want to measure the sugar concentration in honey. Then there is a full description on how to do it, and you can actually download a PDF of the manual itself, where it shows, it quickly explains what to do, what the settings are. It shows some of the results and a quick explanation. So this is kind of a help to you in order to figure out how to get to the results and how to use the different products as easily and comfortably as possible. And all of these are freely available on our website, and as we develop them, we add more and more on our website.
Just to comment from our side on instruments.
Yeah.
I see you're working 190 to 1100. So for this particular application, that would be typically the USB 2000s and later ones. So yes, it would be quite a bit quicker than what you're using now.
Yeah.
And also quite adequate. So I think that there's no real problem with choosing one of our devices. Ocean Insight is not too keen to export the red tide. It's more a teaching device than a measurement device for production. Okay. So they would rather we take up the next level.
Yeah. So the only reason why I'm using 190 to 1100 here, that's because that's what this instrument is currently configured to do. I can do with a smaller wavelength window, but for all intent and purposes, I always try to get as much of the wavelength as the instrument can give me, just because that using this software, I can always go back and reprocess the report. So if I decide that I only need to look at 600 to 800 nanometers, and then suddenly I figure out I want to add an OD at 400, then I can't do it. Whereas if I capture the full wavelength, I can always go back to the report and add ODs or anything like that.
Yeah, that makes sense. On the one hand, on the other hand, whether we have UV and then up to say 900 or 1100, there's no difference in cost for the instrument. So we can go up to 1700, probably staying in the same price. So.
Yeah. Right. So while this is scanning, then I would like to show you another thing that we just made. So I know I've mentioned this to you before, but we actually offer as a service development of let's call it data science on data. So if you press on this Colab here, what you see is that we actually have a list of different scripts that we have made for our customers. So for instance, if I go in here, then you can see we have made a series of tests that we have generated into a report, and then you just need to run this script, and then it will give you a simple pass or fail state. As you see here, is that the concentration of this was not sufficient, so therefore it failed. And this is something that we develop as a service for our customers, and depending on the type of customer, we either publish it here or the customer keeps it as their private thing. And the good thing with Colab is that it's open source, so when we have developed it to them, they can come in and edit in it as much as they want, meaning they can adapt it for any further use as well. So that's kind of a future proofing of their quality control.
So Jade, we have to notice that a new company coming up in KwaZulu-Natal making titanium dioxide might be something a lot cheaper than what they're looking at now.
Yeah, so I have manufactured titanium before. So normally when you manufacture titanium, you would use a DLS for Melvin synthesizer, and it will probably cost them around 80 to 100,000 euros to get the equipment. On top of that, you need to continuously calibrate it and have an expert performing the experiments. Here you just need a simple UV station, and we can actually do size distribution, we can do concentration, and we can also look at some of the attenuation at different wavelengths in order to see that they actually are within their specification.
Yeah, I mean that's important because titanium dioxide is almost black just before it's perfect white.
Yeah.
So you don't want it to be in a transition between the two.
Yeah. Yeah, and also a very important thing is that the way we measure concentration is the volume. So if you would do a first volume concentration with us, and then you afterwards measure the relative density, and then you can calculate how porous your titanium is. And this would be a direct measure on is it a cluster of many small particles, or do you have bigger particles like pigments? And you know, the very small particles, they are photoactive, whereas the bigger particles are more reflective. So it really depends on what you want to design your titanium for. So in front of us now we have the results. So we went from 5 bricks up to almost 14 bricks now. And you can see it already loads the same report as I did before. So I don't need, so effectively I just set up the report format in one way, and that allows me to reproduce this on all of my data sets. So it's really ideal for repetitive quality control and stuff like that. You have all of the different spectrums laid down here, and you can choose which one you would like to see. So we can, for instance here, see that there is a shift between the sample and the crystal, but we could also look at the look at how does the sugar in the DI water change. And here you can see wherever you see dark areas, that's where where there is a small shift, and these are the things that we are tracking, right? You can also save it as an image and append it to a quality report, or you can export it to a CSV file and import it to whatever data platform that you use. Then we have a last thing here is within our profile, you have API keys, which we can create here for the project. And that allows us to do an automatic integration into whatever business intelligence platform you have. So let's say that you have multiple production sites and you have a QA, QC office that is centralized. Then you can use the API keys to have all of the different sites stream the data directly into the aggregate, and then you can have kind of a surveillance function that is directly linked to the measuring station. And the benefit of this is that instead of sending the sample from production to the lab, you just send the data. And the data is instant versus the sample will take a couple of days to arrive. So this is what I had on the docket for you today. Are there any questions to that? Anything that was unclear?
I don't have any questions regarding the process. I think also you've answered the question on which spectros we can get, so that's more clear now. Yeah, I think that's it from my side.
Good.
Richard has any other comments?
Yeah, I would say that if we show our prospective customer this video,
Mm-hmm.
we will already get, they will get a good idea of the benefit of working this way.
Yep.
And then we can work backwards and look at the best instrument that OI offers.
Mm-hmm.
And then what we can do is ask them to send us a demo unit, because it'll be one of those, and then we can do this live experiment with them. I guess we would have to use the link to get the data.
No, so the only thing with the link is it just makes it easier, right? Because you remove one step. But so I'll just disconnect here. So if I were to go in and do an experiment without the link, then you just drag and drop the data here. So effectively, you do the experiment with the software for Motion Insight, and then you save it as a CSV file, and then you drag it in here. So you don't need the link. It just cuts away the requirement of logging into multiple software at the same time and doing the data transfer.
So it makes sense during the demo stage with the customer to work this way.
Yeah.
And of course, once they become a daily practice, then they would rather sign up for the link system, because it more or less cuts any errors or potential errors out.
Yes. Yes.
So they just have to pay attention to the quality of the filling of the cuvettes.
Exactly.
The cleanliness of the cuvettes.
Exactly. So you can look at it as like an upselling cycle, right? So the NanoCuvette allows them to do new novel measurements. The link effectivizes their work. So it really depends on what they want to do. And they can even use the platform to do their standard measurements. So we have designed it so they don't need our cuvettes in order to use the platform. So our intention is to migrate as many as possible onto SpectraWorks in order to have a one platform to do all of your spectral analysis.
I think it's really an innovation which takes a little bit of time for people to accept. But
Yes.
I think we are fully acceptable. We can see what's happening.
Yep.
My apologies that our whole project is taking so long. But right now in our office we're sitting without electricity, which is one of the gifts of the living in Africa. You not only get beautiful sun outside, but sometimes none inside.
Yeah.
So right now we're sitting with torches and running on batteries and inverters.
Mm-hmm.
So things have taken a bit of time, but the next step now for us is to present this to our customer who's keen to get something new. They're also an early adopter.
Mm-hmm.
And we've worked with this company and this person for quite some years. So it's a good opportunity to start there. A fairly simple test, but as we can see, a very reliable test.
Yeah.
So from my side, thank you very much for your demonstration and your teaching with us today. And
of course.
Thank you, Jane, for putting it up together. Appreciate that a lot.
Yeah, and we will gladly repeat a session again if you have a group of individuals, application specialists, some customers. We will gladly repeat. I know you don't have a SpectraLink right now, so if you want us to just showcase the SpectraLink digitally like this, then we will will gladly support you in penetrating the market, because it's a mutual interest for us, right?
That's perfect cooperation. Thank you very much. And we are busy looking at the distributor offer. It always takes a little bit of time because we always have to give it to some legal person who's always on holiday.
Yeah.
But anyway, we will get back on that.
Yeah. So for the distribution agreement, and I wrote this to Jade as well, is that right now I have a time sensitive offer of no upfront commitment from your side because I'm going to Web Summit in the first week of November, and one of the things they measure me on is growth, vaguely described as, you know, growth. So the board have decided that whoever I can onboard of new distributors within this time, then there will be no upfront commitment in order to stimulate the appearance of growth, even though it's not revenue based.
Yeah, of course, we live off making sales.
Yeah.
So our motivation is not to not become a distributor, but it's to make some money for both of us. So
yeah.
In our case, if we sign this, and Jay, let's just make sure we get the date and time right. But the point is, if we want to do this, and we are doing it as such, we might as well claim. And of course, once we become a distributor, we will be in the business of trying to sell the stuff.
Yeah.
So the world has been crazy for the past 2 years, but we still have customers and we still have new customers. So,
good.
So yeah, I think it's a good opportunity, and we need to look at that more closely. And I think I'm personally convinced of this nanotechnology, and I think that we do something like bricks, which people have been doing since hundreds of years almost. But this is such a novel way; it's going to complete. And you're talking about, in effect, hijacking just about every spectral measurement down the line.
Yep.
So that's the dirty secret we won't tell everyone. We have a spectrophotometer from Konica Minolta that we call a Swiss Army knife.
Yeah.
Because you can measure so many different substrates in so many different ways. So most people these days, they buy for the lab, they pay their 10,000 euros or 100,000 euros, and they can only do one thing. Whereas we're saying, you can pay much less and you can get many things, and this is another example of that.
Yeah.
And just a last comment from my side, when the mobile phone was launched by Ericsson or whoever, everyone said nobody in Africa will buy them because they're too expensive. This is only for bosses. Well, the bosses here are all riding bicycles and running small businesses because they had no telephone. There was no telephone.
Yeah.
So once they found out that they could share this with 20 people in their family, everybody. So we now have, I think, 2.5 mobile phones per citizen in South Africa. So we were like Norway and Sweden and Denmark in the beginning.
Yep.
So we don't mind crazy stuff as long as it works.
Exactly. and our ambition is to replace all of the specialized instrumentation like a DLS or a nanodrop system with a consumable in order to make the testing approachable, right? Because the more approachable the testing becomes, the more analysis will be performed and the more value we can create, right? Because having a centralized testing laboratory, the infrastructure and maintenance cost on that is really high and often prohibitively high. Like for instance, in Denmark, just doing water well testing is an extremely cost for the Danish society. So they have these people driving around to the different water wells, collecting water samples, driving them back to a lab, and it takes them 2 to 3 weeks before they actually get the results. And we have proven that we can do the same in field within 15 minutes. Right? So it's
exactly. Not only that, that is so important is that with our color measurement devices, the inter-instrument is very correlation, whereas with a lot of spectroscopy devices, you can do the same thing and get quite a different result because of the internal settings.
Yeah.
So this way, the cuvette is controlling the reliability.
Yeah.
So that is to me the big deal.
Yep.
Because that's turning any device into a standard.
Yes, that's our secret agenda. So.
I'm sorry, I did say that loud.
Yeah, yeah.
Quick, burn this video.
Burn upon reading, right?
You have to swallow the dust.
Yeah.
Okay, so thank you very much again from our side. I think it's great, and Jade, we must just get on with looking at the. Our finance department has a look at it, and we will now rope in our customer to explain to them.
Perfect.
So from our side, thank you very much.
Yeah, thank you, and have a good day and good weekend when you reach that point.
Yes, it's almost here for us because in Cape Town it's already half a day. So
Yeah.
we have to deal with Nigeria at 2 o'clock.
Yeah.
We have customers in Nigeria, and depends which language we all speak if we finish.
Yeah.
Thanks very much.
All right.
Bye-bye.
Take care. Bye.